Assalamualaikum warahmatullahi wabarakatuh.
My name is Aqsha Yamani,
And my name is Razzaqu Armidzy.
and this is our Ares-8 Rover presentation. So, I'm currently studying in SMA Kharisma Bangsa as a 12th grade student. I wish to study mechanical engineering overseas, and my goal in this competition is to learn more about mechatronics and hopefully enter the finals.
And same as Aqsha, I'm currently studying SMA Kharisma Bangsa as a 12th grader. My target for this competition is to gain knowledge and experience from assembling mechanical parts.
So, I'm first going to explain the background. So, Mars exploration missions so far that has been conducted by NASA, such as the Curiosity rover, is more primarily focused on getting samples and learning the science behind the planet Mars. But with the increasing focus on human missions to Mars in the near future, the need for a rover capable of assisting or rescuing astronauts becomes critical. The Martian environment is described by its extreme terrain variation like craters, boulders, soft dunes, and reduced gravity. The usual rover design may not be able to sustain in those unpredictable terrain, and additionally, it couldn't even rescue astronauts. Thus, a rescue rover must be agile, terrain adaptive, semi-autonomous, and reliable over long duration and distances. The Ares-8 rover is designed to bridge this gap by offering a versatile usage that balances terrain handling, maneuverability, and rescue capability.
And next, I'm going to show you how our solution is to this problem. So, the Ares-8 rover is engineered to operate efficiently in the harsh Martian environment using principles of classical mechanics and robotics. Due to Mars' weaker gravitational pull of approximately 3.721 meter per second square, with the formula of weight equals to mass times gravity, uh, the vehicle's mass is significantly reduced compared to its weight on Earth, which in turn reduces the ground pressure and help minimize wheel slippage and wear. Additionally, to help the rover move better on Mars rough terrain, we added pivots to all four wheels. These pivots let the wheels rotate, making it easier for the rover to climb over steep rocks. On top of that, there is also a camera that can pan 360 degrees so that the remote driver can see where they are going. Another thing is we also added a radar on top of the rover to help detect the astronauts using the signals that are emitted by the suits. And finally, we used infrared sensors to help locate the astronauts in Mars using its heat locating capabilities. And so that we have a sustainable energy resource, we use solar panels as energy generators to maintain the power usage of the rover. When it is on a mission, it doesn't need to rely on huge amounts of battery. As we know, we use pivotable wheels, so we use torque to rotate the limbs of the wheels to change according to the terrain. To transport the injured astronauts who have multiple seats on the back so they can rest while we transport them to safety.
So, in our ideal prototype design, we have the radar, camera, and the infrared sensors that is mentioned by Razak, and also the seats in the back. But due to lack of time and resource, uh, in our actual design, we couldn't actually add the radar and the infrared sensors and also the seat. Additionally, the wheels we couldn't really get them to work of rotating and to help the rover to climb steep rocks.
So basically, we don't have the pivots to move the wheels according to the terrain. So instead, we just use four wheels to make it look like
Like
this.
it
Yeah.
has our ideal prototype design. So next I'm going to explain the circuit diagram. So we have four main components, which is the battery, the L298N, the ESP32 that is compatible with Wi-Fi and Bluetooth, and also our servo. So first we connected all four motors to the out ports of the L298N. and we connect the ESP32 to the L298N so that we could actually control the rover using a controller. Next, it's the same for the servo, where we connect the servo to the ESP32 so that it could also be controlled by the controller, and then it is then connected to the L298N so that it could get actually power from the battery. So next is our demonstration. So now I'm going to demonstrate by controlling the Ares-8 using this basic controller. So as you can see, the car can move forward well, turn right and turn left too. And now I'm going to try to move this tape using the gripper in front of the car. So now I'm going to explain how the wheels on our ideal prototype would work. So if this box was a steep surface or a steep boulder, the wheels on our RS Rover 8 would go up against the steep surface, and the wheels would pivot on a wheel like this, and now the rover is on top of the steep surface. That's it. Thank you. Thank you for listening to our presentation. I hope you enjoyed our explanation. Assalamualaikum warahmatullahi wabarakatuh.